Thank you, Andrea. I hope all is well. Looking forward to another great week with altE and the conference. Really appreciate everyone participating here. OutBack, we're excited about the altE conference, but we're very excited about our new Mojave ESS energy storage system. So my name is Bill Doherty. I'm the National Sales Manager here at OutBack Power. Mark Mays, AKA the Godfather, is the Senior Technical Application Specialist here at OutBack. Mark's going to be going into the UL listings of our product as well as more details. But OutBack, we're excited also about the raffle for the Mojave ESS. The 8 kW AC coupled inverter is along with our 15 kilowatt hour Mojave lithium NMC technology that we're going to raffle off Thursday at the 3 to 4 o'clock session. And also for the 3 to 4 question and answer sessions throughout the week, Mark's going to have the PV simulator up and live for us to check out as well. So it'd be great if you could attend that. So the Mojave ESS is an all-in-one unit. And right now it's AC coupled only, DC coupled come Q4. But the inverter is manufactured in Bellingham, Washington, where it's assembled right there in Bellingham. The 15 kilowatt hour lithium solution is assembled in Spokane, Washington. So these are both US assembled products, which is really unique on the lithium side as well. The inverter itself, transformer based, field serviceable, very similar to the Radian. Has a built-in Wi-Fi hotspot, which is ideal for those off-grid applications that it's a challenge to have internet connection. Revenue grade metering, smart voltage motor start, and the ability to operate with a generator. The 15 kilowatt hour lithium NMC, 10-year warranty, 3,600 cycles at 80% DOD with a push through of 46 megawatt hours. So very robust battery, and it is designed by EnerSys. So OutBack, we're part of EnerSys now. EnerSys, one of the largest battery manufacturers in the world. And actually, on the James Webb Space Telescope that NASA recently launched, there's EnerSys lithium batteries on that telescope. So if NASA's comfortable with OutBack, I think you and your customers can be as well. So the AC coupled product is going to be available. It's actually shipping in March, the complete ESS. Then the second round is actually going to be shipping in May because we've already sold through that first round of ESS. So the winner of the raffle most likely is going to receive that complete ESS, the AC coupled with the 15 kilowatt hour lithium in May. And then the DC coupled inverter with battery, that's going to be available come Q4. So we're really looking forward to the DC coupled as well. And actually in May, I do believe you're going to be able to purchase just the 8 kW AC coupled inverter or the lithium solution on its own. So with that being said, let's hand it over to Mark, tell you more about Mojave, and looking forward to this presentation. Thank you, Mark.
Okay, thanks, Bill. And thank you, altE, for allowing OutBack to be present again at your wonderful annual conference. I think this is like my 7th year in a row or something like that I've been here. And it's always one of my favorite ones because it's just almost completely installer-based attendance and get to nerd out with all the other techies here. So I always enjoy doing this. Just wanted to let you know this title that you're seeing right now, Adding Storage to an Existing Solar Energy System, is an updated presentation of the one that we had listed with NABCEP. So this is the title when you go and redeem your NABCEP credit. This is the title that you will use, not the title that's with this session that we promoted. So just to let you know. Okay, and it's 1 hour. So this is a 2-hour course. You can only get 1 hour. Okay, so I have whittled this down into a 1 hour presentation. So with no more further ado, let's go ahead and get started here. So here's today's agenda. We're going to talk about what is a UL 9540 energy storage system? So this first edition came out, I think, in 2016. There was an update like 2018, I think really wound up, I don't know if it made it into the, which code cycle, because there's NFPAs, there's all these different alphabet soup compliances and regulations that's really kind of difficult to keep track of. But bottom line is UL 9540 energy storage system, at least by the 2023 code cycle, will be pretty much mandatory, and we'll talk about that. We'll also talk about AC versus DC coupled inverters. What are the energy storage options, from OutBack, and how to commission a UL 9540 ESS, basically the Mojave. So that's our agenda. So here's the Mojave as you might see it, minus some conduits installed into somebody's garage. So why UL 9540? Well, peace of mind for energy storage customers. A lot of people, I remember my early days at OutBack, they'd get a pallet full of parts and some, few strings of batteries and kind of piece together a system. And some installers did a really good job of it, and some did not, and some were problematic. So, and with lithium being a little bit more of a volatile chemistry than that lead acid AGMs, they really wanted to make sure that UL 9540 focused on that and really made sure that people had a safe, tested, UL listed, certified system in the house. So 49 of the 50 states have adopted the International Residential Code, the IRC, requiring UL 9540 listing for an energy storage system. Okay, so there's a lot of local jurisdictions that aren't, really enforcing this of yet. And it could be, I talked to one installer from Vermont, told me that, they don't even require permits, for most towns don't, and for residential. So it's really kind of depends on what you do. I know that when I get a tech support call escalated to me, I usually ask for a copy of the single line. I'd say probably half the time one doesn't exist. So if there's no single line, it probably wasn't permitted. So I know there's a lot of stuff going on out there, but if your state is part of the IRC, they've adopted UL 9540, this is what you have to do if you're permitted and inspected, okay? And really it eliminates that poorly integrated system. And the other advantage, UL stamps on the entire system, and that's gonna expedite your project permitting and approval. So that's going to be a big deal, especially if you're in a place where the local planning board is slow on granting permits. So this is really, in addition to the compliance, we have a long-term commitment to safety and performance, and we feel like this is going to be good for everybody in the long run. So what is exactly UL 9540 equipment? So it is a UL 1973 certified stationary battery pack, okay? And a UL 1741 certified inverter. Well, a lot of companies like EnerSys, OutBack included, do not have a UL 1973 certified listing for the batteries. And so a lot of AGM manufacturers, including OutBack, are kind of scrambling around to get their batteries relisted. And I'll talk a little bit more about that in a little bit. So it is a UL 1973 certified stationary battery pack. A lot of battery manufacturers are in the process of getting it done or have it done. And a UL 1741 certified inverter. Nearly all inverters meet this UL 1741 requirement. And so the process is this rigorous thermal and electrical testing to ensure that there's an integration of a high performance system. So the batteries, they actually do, you can see this, they actually do a crush test on the battery. short circuit test, fire, punctures. So they really kind of run it through the mill. So some of these tests are different, like our batteries are UL 1989 listed. Some of these test procedures that they do are a little bit different. But it is required for the UL 9540 listing. Okay, so this NRTL, these are nationally recognized testing labs, could be CSA, could be UL, could be Intertech, I think is another one. So there is a possibility of getting a DC ESS. And that's what a lot of battery manufacturers in the process of doing right now. They have like a battery rack or battery cabinet, and with the batteries inside, and they'll submit that for testing, and they'll get a DC ESS, and the mark will be on the battery or on the battery rack. And that can be paired with any, or I shouldn't say any, but most UL 1741 listed inverters per the manufacturer's instructions. So the battery manufacturer will have to list, you know, which inverters that DCSS will work with. Okay. Now there's also an AC ESS, and that's marked on the shared enclosure. So that would be, the example would be a Mojave. That's the inverter and the battery as one unit. In a multi-part ESS, it could be on the battery or the inverter. Okay, so and those pairings will be per the manufacturer's instructions. So the prerequisites, as I said before, are UL 1973 and UL 1741, and it is required by NEC and the IRC for most stationary ESS products. So there's a little bit of confusion about, say, what is UL 9540A? So what it is, it's a NRTL test method, right? It's not a listing, not a certification. There's no pass-fail criteria per se, okay? But there is a report, you know, like because one of the things that they do is they do a mandatory thermal runaway. Like on lithium batteries, they have to take some heat blankets around 7 cells and force a thermal runaway and see how many adjacent cells would also thermal runaway from that. How would it progress? So this testing corresponds with the requirements of the IFC and the NFPA. And what it is, it's data for the HJs to determine site-specific requirements. If some kind of fire suppression or other mitigation would be required for that battery. And let me go back here. So what would happen is the system designer would say, okay, this battery, passed, or the test results looked really good with this. There was no progressive thermal runaway. There was no dangerous outgassing, blah, 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 blah. I'm going to go ahead and recommend a bigger system than what's allowed. And that's coming up here shortly, I believe. Yeah, so the second edition. So UL 9540 second edition requires a 20 kWh battery bank maximum, 50 kW for non-residential. If you want to go more than 20 kWh, then then as the designer, you look at that test report, and typically the battery manufacturers say, hey, we tested with 3 battery cabinets, and hey, there was no significant progressive thermal runaway, there was no dangerous outgassing. You probably won't even need to worry about any additional mitigation. If there was some slight outgassing or some thermal runaway, then maybe the HJ will say, okay, you can put more than 20 kWh in here, but you're going to have some additional, fire suppression or, toxic gas mitigation, whatever, So it's not quite as straightforward if you want to go more, but with a good glowing test report, it shouldn't be a problem. We expect that we're going to have that with Mojave, but I'll talk more about that later. The other thing is that there's a minimum 3-foot spacing between batteries. So if one does catch on fire, it doesn't spread to the others. Again, if the UL 9548 test report was done with closer spacing and the results were good, then the HJ might say, okay, looking at this based on this test report, they did it at 12 inches apart and there was no problem. So we'll go ahead and okay the system, have them closer spaced and, and more kWh. So that's kind of what happens there. So again, that's kind of what I just talked about here. So there's a flammable gas release report. So, okay, so lead acid AGM batteries. Now here's the tricky part. We've been using lead acid AGM batteries since I started OutBack 11 years ago, and it was never really an issue. But I downloaded a white paper from UL. This is a white paper from UL, and this is kind of what some of that had to say. So the 2018 editions of the IC, RC, and the NFPA 1 fire code first introduced requirements aimed specifically at modern ESS applications with a focus on lithium-ion battery installations, okay? They said an ESS using lead acid or NiCad batteries that fall within the scope of UL 1778, which is a standard for interruptible power supplies, and only serve as a UPS, are outside the scope of UL 9540. Well, this left a lot of people scrambling. So if your batteries were under 1778, which were mostly for like commercial telecom sites, cable TV front ends and stuff like that. So they kind of left an exception for that, okay? So, but a lot of people like in our industry, if the code is strictly enforced, if you're not a UL 1973 battery listing, technically you can't be a UL 9540, and technically that doesn't meet UL 9540, and it doesn't meet the IRC's requirement to have a UL 9540. So let's take a look at OutBack. So our batteries are listed to UL 1989 for standby batteries, which includes, amongst other things, UPS applications. And that's kind of how we've sort of been able to not get around anything, but that's how we're, and the EnerSys batteries, which you see in this photo, I mean, they've been used in telecom sites for like decades, right? These AGM batteries, and nobody's saying, oh, these aren't safe, because they are tested and they are UL listed, just to a different standard. So if OutBack system is considered as a UPS, then it could be approved by the local planning board depending on their interpretation. And if you look at this, UL 9540 was really a focus on lithium-ion batteries, and as a UPS, there's an exception for UL 1778, where UL 1989. Would they allow it? It's up to them. It's kind of a gray area, but with this next code cycle and stuff, with UL 9540, technically speaking, they need to be a UL 1973. And if they denied it, then they would be within their rights. If they approved it, saying, hey, there's no, it is UL, it's been UL 1989 tested, you really have to go with ultimately what the local HJ is going to say. Okay, so that's where it's at. And OutBack, like others, are still in the process of getting their AGM batteries UL 1973 listed. I imagine that there's going to be a lot of states that are going to allow AGM batteries, or some local authorities, but really before you do an AGM battery system that is not UL 1973, I strongly urge you to talk to your HJ and get their interpretation, because it's a little bit gray. It's becoming less gray as UL 9540 is pretty much spelling it out now. So, okay. So now we're going to take a look and look at an AC versus DC coupled systems. You know, this is a typical DC coupled system. You have a DC to DC converter called a charge controller. Some people call them solar chargers. They take the uneven power coming off the array, they regulate it, convert it down to a safe regulated battery voltage. And then once the batteries are full, that can be sent to the inverter to power the protected loads. Any extra energy that's left over can come out to the main panel loads. Anything left over from that can be exported if you have a net metering agreement with your utility. Okay, so that's basically how that works. And likewise, you see these bidirectional arrows, so we can use the grid to charge the batteries. The grid can power loads, so it can go both directions. Do we have any questions yet, Bill? Is there any, like, are you monitoring the chat to see if we have any?
No questions yet, but I'll jump on them when they're there.
Okay, we don't have tons of time for questions, and if we run out of time, we can handle it. You can stop by our live chat room later.
Yes, from 3 to 4 today.
Yeah. So AC coupling. AC coupling came about because if you have, like, this is a standard, what we call grid tied inverter or grid dependent inverter. They need synchronization from the grid. So they can only export power or actually be active, even to handle the local loads. When they're synchronized to the grid, you lose the grid, you lose power. A lot of customers weren't aware of this when they bought their batteryless PV system, and the power goes out and say, hey, I got all this solar. Why can't I use my solar? So they need that heartbeat from the grid to stay alive. So what we can do with a storage-based inverter is we can kind of insert that in the middle here. So we take some of these loads over here on the main panel, put them in a protective load panel. And basically in this mode with an active grid, we're just acting kind of like a copper wire, if you will, from this grid tie inverter, because it used to be over here to this connection. But now it's gonna, the grid tie inverter, this panel and our inverter are all in parallel. This kind of looks like they're in series, but they're actually all in parallel. And so we provide that heartbeat. Okay, and any surplus energy stored in the battery. So at the end of the day, when there is no more solar, then we do use the grid to power loads. Again, we're just in a pass-through mode. And the batteries can be charged from the grid if that's parts enable. Okay, so one thing that's is kind of unique about Mojave is there are some external CTs. So let's say that we decide to go off grid during a peak demand period. And I know a lot of you are from the East Coast, and there's not a lot of tiered rate structures like they have in California and Hawaii. But I believe Massachusetts and New York, is that true, Andrea, that are starting to have some tiered rate structure?
So far, yes, Mark.
I'm sorry?
So far, yeah.
So far, it's just Massachusetts and New York. So
yes,
so what you can do if you're in one of these expensive tiers, which typically are, you know, in a peak demand period like between 4 and 8 or 4 and 9, you can use this time of use schedule. So okay, at 4 o'clock, we're going to quit importing power from the grid. Okay, and we're going to use solar power if it's active. 4 o'clock, might not be getting that much energy there. So it could be blending power from the PV array and energy storage tier to provide power to the backed up load panel. And the Radian can do that. We have, you know, the grid use timers there, but with the external CT, we can let energy flow out to this main service panel, and we what we call zero the grid right here. So we make sure that we allow energy to go to the main panel loads, but no further than that. So we're using just enough energy that we need to. So what's kind of nice is because a lot of times your main panel loads are some of your bigger loads. So by doing this, this grid zero with external CTs during time use period, we can include both load panels. Okay, and then during a grid outage, we become the heartbeat, the synchronization, if you will, for the grid-dependent inverter to stay on, power loads, and charge batteries if necessary. If load demand exceeds what's being produced, then we can blend power from the inverter with a grid-dependent inverter to keep those loads going. And then at nighttime, it just works like a regular off-grid system where we're powering loads from the battery. Okay. So what are the UL 9540 options from OutBack? We have a DCSS. We have a 2-shelf and a 3-shelf IBR3, IBR2, -175. And then they have a -LI in their part number for lithium. And that, you can't put any lithium, since we did our testing with Simplify, you can only use Simplify batteries in those racks. But that does, provides essentially a DCESS that you could use with, say, a Flex Power Radian or Mojave at some point. We'll probably be selling Mojave inverters by themselves, so you could use other battery systems right now. Initially, we're just going to be selling them as a system, and but these are basically your two options. This over here is a DC coupled option, and then over on the right is an AC coupled option. Okay, so let's kind of compare Radian and Mojave. So the Radian, Flex Power Radian comes with the two 7,000 watt charge controllers, the Mate 3 system controller, battery monitor, and a pre-wired system. So you can get that in a 4 or 8 kVA. With Mojave, it's an 8 kVA. This is a transformer-based inverter. So it has good surge. The spec is 10 kVA, but it has kind of a unique, rather than trying to support both voltage and current, it just supports the current. So it will support the maximum amount that we're specified to provide, and it will allow the voltage to sag, just so we can put all of our regulation on the current. Because most devices that cause sag are like motors, compressor motors, pump motors, and those are the ones that are current-based devices anyway. So it looks like it's a lot less than the Radian, but the way we do it, I put the little plus sign there because it really, you know, the testing we've done in our lab shows that it's really a very robust surge inverter. The other thing, the advantage that you get from a transformer-based inverter versus a transformerless is the phase imbalance. So we can handle up to just under 4,000 watts of phase imbalance. So you can get 4,000 watts almost on one phase only, and not have the inverter fault out on you like some transformerless inverters do. Time use support is basic, you know, with the Mate 3. We have the grid use timers. With time of use, it's pretty advanced with Mojave. There's, you know, we can, with external CTs, we can kind of do whole house self-consumption, well, which is pretty nice. The Flex Power Radian, 6,000 or 12,000 watts. You can have actually up to 7,000 or 14,000 connected watts. So you can have an array at nameplate that's either 7,000 if you have the 4 kW version with one charge controller, or with 2 charge controllers, you could have 7,000 each. That's connected watts. It's only going to convert 100 amps times whatever your battery voltage charging is. So, okay, so AC coupled to 8 kVA. Mojave, the way it AC couples is absolutely amazing. I did this, yeah.
I'm sorry, we do have one question
Okay.
that I wasn't able to answer or didn't want to. What manner of control are you using for AC coupling so that the solar inverters do not overheat when off grid? For example, phase shifting, communication protocol, or both?
Yeah, so we use a frequency shift method to control. They're now called, used to be called frequency watt. I think now UL 1741 2018 is calling it frequency droop. It's all the same thing. So that's what we're using. And the amazing thing about Mojave is how well it does it. It does it incredibly well. And the other thing is there's some new architecture design in the power flow inside of it, whereas the Radian used to have to just like disconnect from the grid to control that path coming in. So with Mojave, you can say, okay, I'm not going to import power from the grid. I'm only going to charge batteries from the grid-tied inverter. So what we do is we only allow battery charging from the AC output port, not the AC input port. Now we can if you choose to, but if you choose not to, then we won't. And if the load demand exceeded what the grid-tied inverters is doing, then we could actually blend power from the grid to the load, and then the load demand drops back. Then we quit importing from the grid and we continue charging from the AC output port again. And we do this really, really well. I mean, I show in the video that we're going to show in our sessions. It's a 21-minute video, and it shows all these different things. You can have the loads go on, off. I've been testing one of our competitors' units on AC coupling. You pick one voltage, like 54 volts or something, and it kind of regulates plus or minus half a volt, 0.6 of a volt, kind of like Radian. But the Radian will at least allow you to do some level of 3-stage charging. And the other one, when I looked at the PV simulator, the power from the PV simulator is going from 200 watts to 2,000 watts, back down to 200 and up to 2,000. So it's just going up and down and up and down and up and down. And whereas, Mojave, it just sits there and regulates so tight, like within 1/10 of a volt, or sometimes just spot on. And so that's why I would never recommend AC coupling, in a daily cycling application, and especially with lithium batteries, because lithium batteries are very sensitive to overvoltage. And I've seen problems AC coupling to lithium battery systems. But with Mojave, I would have no problem whatsoever recommending Mojave for off-grid, daily cycling, whatever you want to do in an AC coupling application with Mojave. It works that well. I would not recommend that for the Radian. I would say with Radian, it's better if you're going to AC couple with a Radian, or from the competitive units I've seen so far, it's better that's just for emergency backup applications, a couple weeks out of the year. But I would never recommend AC coupling with a lithium battery ever under any circumstance. It's just, unless it's a Mojave, but it really, it regulates that battery voltage just like a DC coupled inverter does. Okay, so off-grid for both, yeah, AC coupling with frequency watt support, that's how it does it. They both have really good battery voltage regulation. And with FP rated, I'm talking about DC coupled. Okay, so installing the Mojave. There is a couple brackets. There's a wall bracket here. There's these two battery brackets here on the bottom. You can see they're positioned just above the inverter. And there's a couple little places that keep it up. It's 465 pounds, so it's not likely to fall over. And one of the reasons it's so heavy is it did come from EnerSys sells a lot of forklift batteries. So forklift operators have been riding around on top of these batteries for a couple of years, and the extra weight is actually a plus in a forklift application because they need that counterbalance on the battery, acts as a part of the counterbalance. So, but anyway, the other thing that makes it so heavy is there's these metal shields inside between the cells, and that's there for safety and in case of the forklift application for weight. But it provides a lot of safety, kind of like a firewall between cells to help limit any propagation of any, if there is a thermal runaway in a cell or cells, that it's not going to spread throughout the battery. So that's one of the reasons why we think we're good on our UL 9540A test that we will do, because we are going to allow stacking these batteries. We just need to get that UL listing for it and work out a few technical details, and then we'll be able to stack Mojave batteries. Right now, it's just one battery, one inverter. We're going to be stacking probably, well, at least initially up to 4 inverters, but that's again coming later this year. But for now, we do provide this conduit. We provide the wall brackets. You need to hook up the battery. So there's the 4-aught cables here. Then there's a grounding wire here. And this little purple wire here, this is the CAN bus cable. So this comes from here. It'll come up, and this is showing it in a vertical position. That's actually in a horizontal position. It's right up here. Again, it's not in the vertical plane, it's in the horizontal plane. And you just plug up into that port. So how do you move a heavy battery? Well, there are tools for this. So this is Jorge Guzman. He's installing a Mojave battery at his home. And so these are like furniture dollies, the hand trucks. And so you can see, you should probably have 2 people when you're doing this, but you can see he took apart the box, put it in the hand truck, and was able to pull it back and move it by himself. So it's, this thing is nice and tall to give you the leverage. And so it's, the right tool for the job, right? So it is possible to move something that heavy as you need to. So in terms of the AC, this is probably this is very similar to our Skybox inverter. You just land your grid connections here, your AC output connections here, and it comes without this generator breaker. So if you are going to put a generator, you will need to order the circuit breaker, and then you will need to take the front cover off and put these 2 wires up there. On the other ones, the wires are this is already wired up. You just need to put that in there. If you add a generator though, you will need to wire this into the top inverter portion of it. And then this in the bottom, then there's this little shield here for the DC stuff. So pretty simple, really simple. So then when you make those connections, so you mount them up there, you made your AC input and output, you made your 2 battery connections, your CAN bus connection, your ground connection, that's it. If this is a Mojave, it will auto-configure if the Mojave is present. We do have some whitelisted batteries. You can see in the drop down, so under battery model, there is a drop down. You can see there's the kilovolt battery, the Mojave. So you just, There's some preloaded white-listed batteries. Of course, all the EnerSys AGM batteries are all here. Okay, so if you have something not on this list, you would select custom lead acid. You can see that's the default up here. So custom lead acid or custom lithium, and then you would put in the settings for the battery manufacturer. Now, another thing to note here, only use UL 1741 SA compliant grid dependent inverters with the Mojave battery. And that goes back to what I was saying before. If you can't regulate that grid dependent inverter well, using frequency watt, then that can be problematic. And, we don't want, hard to regulate battery voltages, because what happens with the non-SA inverters, they go off at 60.5, just like the spec says. At 60.5 hertz, they shut down. Okay, so that half a hertz is not enough frequency range to regulate the battery. So the battery will go off, 5 minutes later it comes on. Then it shoots up, turns off, starts over. So it goes through this 5-minute cycle of what we call bang bang charging, and it's not good for the battery. If you're going to do it a couple times, couple days, couple weeks out of the year, probably okay on an AGM battery. They can probably handle that, but we don't feel it's safe for a lithium battery. So if you are going to use our Mojave battery, which is your only option in the beginning, it must be with a UL 1741 SA compliant inverter. Okay, it's very important to know that. Okay, so once you select the battery, then you have to select your grid. What are you on? So IEEE 1547-2003, that's the same thing as UL 1741 non-SA. UL 1741 SA, the equivalent IEEE is IEEE 1547-2018. Then if you live in California or Hawaii, there's these other settings. And so anyway, there's some other settings here if you need them. So you choose your grid listing. So you choose your battery, choose your grid. And that's pretty much it. Then you'll just hook it up and go. So compared to any of you that have done setup and programming with other our legacy inverters, I think you're going to be very, very happy with how quickly this installation can go for you using our UL 9540 Mojave ESS system. It's a really nice system. So one of the things I didn't, one slide I did get rid of, I was expecting to see, I'll just talk to you right now. So in terms of battery capacity, it's a 14.8, or we round up to 15 kW nameplate. So we, the default settings that we recommend are an 80% depth of discharge, which is pretty typical, like Simplify and some of the other battery manufacturers, like I think Simplify, they'd say 10,000 cycles at 80% depth of discharge, 5,000, or I think less, even 3,500 at 100%. So we're like everybody else, but the other thing is our 10-year warranty, it is for 80% of nameplate capacity after 10 years. Some battery manufacturers are only 70% or even 60% of nameplate. So read that warranty very carefully. So the other thing I wanted to mention is, so at 80%, at 14.8 or 15 down, it comes down to about 11.8 or more or less 12 kWh. So how does that compare to an AGM? So our 200 amp AGM battery is 8.8 kWh. So if you had 3 strings of 200 amp hour batteries, that's 26 kWh. Okay, and we typically, to have a decent amount of cycle life to the battery, we typically don't recommend going more than 50% depth of discharge. So the effective capacity is half the nameplate if you're going to do 50% DOD. So that's like 13 kWh. So you're looking at Mojave at 12 kWh versus 3 strings of AGMs at 13 kWh. So they're pretty comparable. So you can say that, and you know, if you overshoot that 80% a little bit now and then, it's no big deal on the Mojave. So basically, the Mojave battery is like 3 strings of AGM batteries, and you know, in terms of effective capacity of one to the other. So comparing apples to apples, think of Mojave as the same as like 3 strings of AGM 200 amp hour batteries. Okay, so this is the power flow diagram. You can see that the load is demanding 2.9 kWh. We're getting 2 from the grid. We're blending that with some power here. So we're kind of like this, sort of like a time of use application, if you will, where we're offsetting some of the grid power with battery power. And you can see there's a mix of green and red in there. So that's how we know, excuse me, that is blended. Okay, and then it just gives you voltage on L1 until L2, current L1, L2, the external CTs, what they're doing. So it's really very, very nice interface. So basically you have status for the inverter, for the battery, for the grid, for the generator, and your network settings. And then the settings, same thing. You should just go to the settings, and then it's inverter, battery, grid, same thing. It's very, very easy to use. It's like using an iPhone. It's very intuitive. We do have a manual that explains things in more detail if you're not sure what some of these terms are, but anybody that's an experienced OutBack person, you'll probably never need to pick up the manual, at least from the standpoint of the user interface.
Hey, Mark, we do have one question regarding the generator. Does it go through the transformer to help with leg imbalance?
Does it help to say that a question again?
Does it go through the transformer to help with leg imbalance?
Yes, yes, that's what the transformer does. That's the, you know, goes from inverting to transforming to the transformer. Yep, exactly.
Got another question just popped up here. What are you doing for monitoring / control? Are you committed to local only, no internet cloud connectivity requirements?
Say that one again, I'm sorry.
Are you committed to local only, no internet cloud connectivity requirements?
Yeah, the user interface is all done through whatever device you have, whether it's a smartphone, a tablet, your laptop, desktop, whatever, as long as it has Wi-Fi. And that's how you access the Mojave, is through the Wi-Fi. Now, if you want to use Optics RE, our monitoring system, and of course, there's not enough time for me to go through that. That is part of the 2-hour part of this presentation, is our Optics RE. We have what a lot of people have told us is the best monitoring control in the system. That is cloud-based, that is internet-based. But if you just want to use the Mojave UI, you just go through the Wi-Fi. My desk is 150 feet away from the Mojave. And to get there, I have to go through my door and 3 walls to get to the Mojave Wi-Fi. And I have 2 out of 3 bars on my Wi-Fi. It is a super strong Wi-Fi. And so you're not going to have any trouble. But yeah, you don't have to go through the internet to get to it. Okay, so this is just kind of the last little bit here, and we continue to take questions for another 4 minutes. I know they want us to finish off at 9:55. So the Mojave, like the Radian, is field serviceable. There's, I think, 5 different circuit boards in here, 4 or 5 circuit boards in here. The transformer can be replaced as well. So we explain how to do that in our manual. We explain how to remove the different circuit boards. We are going to, we have like 4 test beds for testing those circuit boards. The first 6 months of Mojave or so, our applications engineering group is going to be actually testing the field returns, just, if there are any, that we can kind of trend them, see if there's any problems. Yeah, that's if there is any problem with the Mojave, and it's a 10-year, right, Bill? It's 10 years inverter and yes, battery, right, Bill?
Correct.
Yeah. So yeah, we got a really great warranty. We really have a lot of confidence in this inverter. I've been playing around with my Mojave here in the test lab since last August, and it's been really reliable. And that was with kind of like pre-production hardware and everything. It's really been very happy with the way it's performed. Okay, so thank you. If you have questions, you feel free to shoot me an email, attend our little networking sessions this week from 3 to 4 Eastern time. And unless there's any more questions, I'll just go ahead and sign off and turn it over to Andrea.
Thanks, Mark. It looks like we do have maybe 2 or 3 minutes left before we have to sign off and let people go to the next session. I think somebody is just asking if you can verify what the lithium technology is of the battery. It's
NMC.
Thank you. And it looks like they wanted, I think you touched on this, where is the Mojave manufactured? Somebody's asking.
Yeah, so it's manufactured in Washington State. I mean, we get a few components outside the country for sure, no doubt, but all the final assembly is done here in Washington State, either in Bellingham, Washington, or Spokane, Washington. Yeah.
Okay, and lastly, have you tested AC coupled with Enphase microinverters?
I have not. We have not done testing with Enphase. We have, with our legacy inverters, definitely. But
all right. Thank you so much. You stuck right to our session time, so we appreciate that. And if you guys, all the attendees, if you've seen the schedule, you know that Mark is going to be doing this session each day for the next 3 days now. So Tuesday, Wednesday, and Thursday, same time, the next 3 days. As well, at the end of every day is the open networking session from 3 to 4 that OutBack will have a virtual booth, we're calling it, so that you can stop in there and ask any questions that you thought of later or didn't get addressed today. And with that, I think we will say thank you and let everybody kind of log off and get ready for their next session. Thank you, Mark and Bill.
Okay, thanks everybody.
Andrew.